Am I audible? Awesome. I have to say, extra thanks for you to be here because the weather is so nice outside. So I came to a conclusion. I've been to Netherlands a lot of times, so I finally figured this out. The weather here is sometimes nice, but the people are always nice. So thank you. It's great pleasure to be here. I want to talk about a relatively new feature in Java, which is the concept of gatherers. And I want to talk about what does it do, and then I'll talk a little bit about how we can use it. But this is a fairly deep topic, and it's impossible for me to cover this in 45 minutes. So I'm going to take you as far as I can until you see the warning sign that says, cross this at your own risk. And I will kind of stop there and say why you may not want to go beyond that. So best time to ask questions or make comments is anytime you have a question or a comment. Just draw my attention, ask your question or comment. I'll be delighted to hear. So let's start with what we know already. Well, Java 8 introduced this concept of functional pipeline. So let's talk about the functional pipeline just for a minute. So here is a little a collection of data that you can see. And I'm going to say numbers right here. And I'm going to call in the streams. And let's do a little filter. And I'm going to say, given an element, I want really all the even numbers from the collection. Let's do a double of the values in this collection. And then do a for each, a system.out, and a print line to print the double of all the even numbers in this collection. So we can see from the output, we only have values 4, 8, and 10, which are the double of even numbers. However, there is a concept we should already know, and this, as we know, is called a terminal operator. So a terminal operator is the operator that triggers the evaluation of a pipeline. If you don't call a terminal operator, the pipeline is dormant. It doesn't execute anything in the pipeline. So those operations are called as intermediate operators. And this is also another intermediate operators. The nice thing about intermediate operators are that intermediate operators are always, if you will, they are lazy. They don't evaluate until a terminal operation actually kicks in. Now, the benefit of intermediate operation is we can pile up all these computations, and then we can evaluate them minimally based on the terminal operation. So in this example, as you know, the terminal operation was printing each of the values, but if it was only interested in the first value, then the filter and the map will not run as many times as it does for each, because they are lazy. Now, one of the other things we also know is that rather than, in this example, as you can see, we got the values 8, 11, and 12. So rather than doing that, we could have literally called a different operation here. For example, we could have said collect, and we could have said collectors in this case, and we could have said toSet, for example. And we could have collected the results into a set. For instance, we can say result is equal to, and then we can come back here and output the result of that collection. So in this case, we know that a collect is also a terminal operator. But what's really nice about this is, rather than calling collect and passing one of the predefined methods, you can implement your own collector as well. And that's a little bit more effort, but we already can do it in Java 8. So from the get-go, from Java 8, we always were able to implement our own terminal operations. However, how do you implement your own intermediate operation? That was not possible. For example, I want to take you back through the memory line just for a minute. If you are programming, let's say, in Java 8, and you have this collection, and you only want maybe 2 elements out of all the 3 elements that could be arriving in this response, as we know. So when you look at this particular code, rather than getting all the 3 values, what if you only wanted 2 out of the 3 values? You know you could call a limit function. And you could have said limit 2 in which case it doesn't give you the 12, so that was possible in Java 8. But what if instead of limit, we want to limit based on a predicate, then a count? So in other words, I want to say, keep giving me values, but the minute the value is more than a certain value, don't give me any more. Well, as it turns out, you couldn't do that in Java 8. And people would often email me and say, how do I do that? And the answer was, sorry, you cannot do it. Well, in Java 9, we were able to do it using a takeWhile function. So the takeWhile function, you can say E is less than, let's say, 5, for example. But takeWhile was introduced in Java 9, not in Java 8. But this illustrates the problem for us. We needed a function that was not available in Java 8. They had to provide it in Java 9, then we get to use it. But how many other things are not there right now? And if they're not there, what do? We could wait for them to provide it, but if they're so general purpose, they may provide it, but if they're more domain specific, there's no way they're going to provide it for us. So the question really we want to answer here is, we got these terminal operators and intermediate operators. We can customize terminal. What if we want to customize intermediate steps? How do we do it? Now you know what gatherers actually do. So gatherers allow you to create your own custom intermediate operations. That's basically what gatherers do. So you can write a gatherer, and you can write your own intermediate step, whatever that step may be. But before you go further, I want to give you a word of caution. So gatherers, I would say, are awesome, and I would just put this word but and leave it for a minute. Now, I want to emphasize one thing. If you're going to write gatherers, that's quite a complex code you may actually end up writing. So what is the difference between a novice and an experienced programmer? A novice says, I'm going to go to work and write code. What does the experienced programmer say? I'm going to go to work and remove code, right? We know that writing more code causes issues for us. So I want to emphasize, I'm going to say knowledge is knowing how to solve a problem. And I want to say wisdom is knowing, right, is knowing when not to do so. So I would argue that knowledge without wisdom is trouble waiting to happen. So I want you to have the knowledge, but I hope you have the wisdom not to do it also. Because this can be really hard to maintain in the long run if you're not careful. So I'll give you 4 steps to using, I would say, gatherer. So the first thing I would say is, see if you can use the familiar functions of the pipeline to solve your problem. This is like filter, for example, right? Filter, map, etc. This is something very important to do. I had somebody email me a couple of months ago and said, oh gosh, look at this. I came across gatherer. I wanted to use it, so I used it to implement this problem. What do you think? And I had to, unfortunately, tell this person, well, that's really nice, but I can solve this exact problem simply using a couple of calls to map and filter. You don't need gatherer to do it. So the idea is, take the time to ask, do I really need gatherer? If I can solve the problem using existing functions, it's much better because you're reducing complexity in your code. No need to introduce that more. The second solution is, if one doesn't solve it, see if there are built-in gatherers to solve your problem. So if there is a built-in gatherer, look at the JDK. Hey, look, JDK already gives you a gatherer, just use it. Not only do you want to look at it, but with every release of Java, just take a few minutes to see if they added more gatherers. Because they already have a way to give us some gatherers, the chances are as time goes on, they may add a few more, so that's a good thing. You say, existing functions don't help me, built-in gatherers don't help me, what should I do? My third step is call a friend and ask them to talk you out of this. So, this is the best, this is why we have friends, right? You call a friend and say, I got this urge to do it, what do you think? They say, let's meet for a drink. Let's go over this, right? And then they convince you, dude, you need to have a good life. You don't want to stay at work all the time. Don't do this. Like, thank you for that help, right? So call a friend. And your friend says, yeah, looks like there's no other way. You have to write a gatherer. Only then, I would say, drink a lot of coffee. And then, work on it to write your own gatherer. So don't just take it lightly. The first step is not to write gatherer. And you may be surprised. Hey, this dude wants to teach us gatherer and he's telling you not to use it. Well, I think it's important to have the wisdom to know what we are getting into before we start implementing it. It's a very powerful and useful concept, but we need to know we are investing the time wisely into it. That's very important. So having said that, I can pause for 30 seconds if anyone wants to leave the room. Okay, so how do we write gatherers? Like I recommended, right? If we have built-in functions that are already available in the pipeline, use them. But there is one problem that's not solved already in Java, the older versions, which is a difference between a reduce and a scan function. If you have used other languages or libraries like reactive libraries, you probably have come across a scan function. So what's the difference between reduce and scan? I'm going to unnecessarily overly simplify this. Reduce gives you one value, which is a cumulative value of the elements in a collection. That's a very wrong definition, but that's good enough for our purpose. So for example, let's look at one example of reduce right in here. So what I want to do is to take this collection that we have, I'm going to say result is equal to, and I want to output that result in the very end of this. So output the result. So in this case, I'm going to say dot reduce, and what am I interested in reducing this to? I'm going to say 0, comma, integer and sum. So when I run this code, you can see the value is 21, but how is it 21? Because reduce in this example set, 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and so on, and so we got a value of 21. So that's reduce, that's already in Java, and I'm sure we all have used reduce in the past. However, what is a scan? A scan is a way for reduce to emit its data while it's reducing. So imagine that integer sum is chatty, it is noisy, it wants to tell you what it's doing while it's doing it. So I could be emitting, pardon me, I could be emitting and say, oh, 0 plus 1, it's 1. And then 1 plus 2, oh, it's 3. And 3 plus 3, oh, it's 6. So I'm going to be emitting the intermediate values and not just return to you the final value. There are some applications where it's very useful to get those values emitted as you are computing the cumulative value along the way. So in this example, as I said, I want to be able to see the value 1, 3, 6, 10, and so on as the computation is performed. So in other words, I want to emit in this case, the intermediate values during reduce, right? That's what I'm really interested in. As it turns out, scan is available in Scala. Scan is available in Reactive Stream API, but scan is not there in Java, at least in previous versions of Java. They could have implemented a scan method in Java. So you could have said, my collection, filter, map, scan, and that would have worked. But they decided, rather than introducing a scan method, what if they show us an example of gatherer to implement the scan method? So I thought that was pretty nice and brilliant way to do it. So a scan is available as a built-in gatherer. So I'm going to say numbers.stream, as you can see here, dot for each, and I'm going to say in this case a system.out, and print it out. But in between, I'm going to call a gather method. So the gather method is a way for you to write your own custom intermediate step. So you use filter, map, and so on. But anytime you want to do your own method, you would implement a gather. So in this gather method, what are we going to do? I'm going to say gatherers.scan. And as you can see, they have a few different built-in methods, as you can see. In this case, I'm using scan. So I want to start with an initial value of 0, but I'm going to say integer sum is what I want to access. So when I run this code right there, you can see it emits the value 1, 3, 6, 10, 15, and 21. Those are the intermediate values it is emitting along the way. So we are using a built-in gatherer, which is called the scan method in this particular example. So that's maybe the first thing to do is to see if there is already a function provided. And that would be the easiest thing to do, is to simply use that if it's available. So this takes us to learning a little bit more about this. So what is the gatherer and what does that do? Well, first of all, notice you are writing a gather method. So what does the gather method actually take as an argument? It takes as an argument an implementation of an interface called the gatherer interface. Well, the gatherer interface is a functional interface. So you want to implement this interface to provide the intermediate operation. But before we go further with it, it's important for us to understand how this actually behaves. So for that purpose, let's just imagine this for a minute. We got these three gentlemen, if you don't mind, I can use as an example. Let's assume those three are the stages in a functional pipeline. Now, you are the first stage, you're the second stage, you're the third stage. But how does the functional pipeline work? We have seen this already, right? The terminal operation can say, if I want more information, or I am done. For example, if you called for each says, give it to me, give it to me, give it to me, and it keeps taking values. But if the terminal operation is a find first, what does find first do? It says, I'm waiting for your data. And the minute you give it data, find first says, I'm done, I'm going home. I don't want anything more from you. So a terminal operation can be asking for more or can tell you when it doesn't need more. But that's not only true for a terminal operation. Think of the example of a limit. If you said limit 3, what does limit 3 do? Limit 3 says, I'm going to need 3 values. I haven't gotten anything. Give me more. You give it 1 data. It says 1 down, 2 more to go. Give me more. You give it the second data. 2 down, 1 more to go. Give me another 1. And when you give it the last value, it says, I'm done. I don't need any more. Don't send me any more data. So going back to this example of the pipeline, what does this do? The intermediate step, what does he do? He says, I'm going to get data from upstream, the one stage before me. And I'm going to do whatever I do, and I'm going to push the data downstream. You can push gently on him, right? So you're pushing the data downstream. But what does your downstream do? He says, thanks for the data, but he's going to send you a desire back to you. And the desire is, give me more or don't bother me anymore, right? And your job is to take the result of push and either pass it upstream to say, hey, the downstream doesn't want any more data, so you don't bother sending any more data. So this interaction is something you need to first be compatible with. So let's think about this, how this actually works. So you have a stage, let's say I, and then you have a stage I plus 1, and you have a stage I plus 2. So somewhere in between, that's what you have. So what does each stage do? Each stage is doing the following, right? So given an element, so after all, elements are flowing through the pipeline, right? So given an element, what does the stage do? The first thing the stage does is do whatever it has to do with the element. So what does the filter do with the element? The filter says, I'm going to throw it away or I'm going to use it. What does map do? map will transform the element. For example, if it's a double of a value, given element, it doubles the value. So whatever its job is, a stage is going to do. So do whatever it has to do with the element. Then, optionally, well, why is it optionally? Optionally because, remember what filter doesn't do. Filter throws away the data. It may not even use the data. So that's why it's optionally. Map will push, but filter may optionally push. Filter says, I don't like this value. Throw it away. I don't want ever to be seen, right? So optionally, push the data, push the transformed data to the downstream, and then return either the stage's desire or downstream's desire to upstream. So I want to pause here. That should actually make sense at this point, right? If we don't understand this part, there's no point in going any further with gatherers. So a gatherer's job is to receive data, do what you have to do with it, push it downstream if you want to push the data, and ask the downstream, what do you want to do? Do you want more data or no? And then send that information upstream and say, yep, we want more data, keep sending it, or no, we're done, we're satisfied. Either the downstream said, don't send me data, or I decide, don't send me any data. In the example of a limit, the minute you hit the limit is going to say, I don't want any more data. I don't care what a downstream wants. I don't want any more data because that's my choice, right? So sometimes it's the desire of the stage. A lot of times it's the desire of the downstream stage. So far, so good? All right. So now that we understand what this is going to do, let's talk about how to implement it in reality. So to understand this, let's implement our own custom filter. Now, before I go, this is one thing you definitely want to be careful about. Never implement a gatherer which does what already functions do unless you're doing a talk about gatherers and you want to give an example about it, right? So this is something you want to avoid doing in work. So for this purpose, I would recommend two things. 1A, spend the weekend programming gatherers so you can learn about it. A great place to start is to implement a filter, a map, functions we already know. And once you get comfortable implementing functions you know, go to more complex functions. And spend the entire weekend, or two if you need to, right? I mean, you got to have something to do on a Friday night, right? So plan these and program and play with it. So at the end of that weekend, you will know how to use gatherers. But then have the wisdom to say, now that I've seen it all, I don't want anyone else to see this, right? Because it's not worth implementing this on real project unless we have a really important business need for it. So you want to really let your business need drive it, not your infatuation to write a gatherer. So this is why I often tell developers, learn everything you want to learn on a pet project and have the wisdom not to take that into production. Because if you take it into production, it becomes a liability of somebody else after you leave. So you want to take the time to learn, but then have the wisdom when to actually use it, because the more we write, the more difficult it is to maintain it. That's what I would emphasize. So let's talk about writing a custom filter and see how this is going to work. So here is a little example of a filter we want to write, our own filter. Now, because we are writing complex code, doesn't mean we write unmaintainable code. This really comes to a discipline. It's a skill we need to take the time to develop. And sometimes we will have people write really, really bad code and say, I had to write it because it is complex or it needs performance, all these excuses. So you can always write maintainable code if you have the desire to write maintainable code. So I'll show that to you here as well with a small little step you can do. So here I'm going to say numbers.stream again. We'll go through a for each function, print it out right there, and say print line. And in this case, I'm going to say a gather. And what am I going to do here? To the gather, I'm going to pass a custom filter. And what am I going to pass to the filter? I'm going to say, given an element mod 2 is equal to 0. So we're passing that to say, I only want even numbers from this collection. So this is something I try to do quite often, is I try not to stuff more things into the gather call, because the more you put there, the harder it is to understand the code. So just call a function and just say, I want to implement a custom filter. Based on your domain, whatever that function is, you can call that right there. So in this case, I'm going to implement my custom function. And what am I going to do within my custom function? Well, this is going to be an integer that I'm going to receive. I'm not going to use any state, so I'm going to leave that empty. I'll talk about that in a few minutes. And then I'm going to say this return type is going to be an integer as well. And what am I going to pass over here? Quick question. Anyone wants to take a guess? What's that going to be? Thank you. A predicate. Awesome. Exactly. You nailed it. So it's a predicate of integer. Beautiful. And that's a predicate. Why is it predicate? Because that's exactly what you're passing here. That's a predicate. A filter takes a predicate. Beautiful. Lovely. So we pass that in there. So what are we going to do next? Well, now I want to implement that particular code. So we can implement our own interface. We can write our own anonymous inner class. Again, the more code we write, the more ugly it is, the harder it is to maintain it. And Victor Klang was one of the key developers behind the gatherer concept. And beautifully, they decided to provide a nice set of factory methods, convenience methods to create gatherers. So you don't have to fight your battle to create gatherers if you choose so. So all you do is gatherer dot of sequential. So, and I'll explain what that means in just a few minutes. And I'm going to say underscore element comma downstream, and then I'm going to specify right here, what do I want to do within this? Let's pause right there and understand what these things mean. You know what element really means. Element is the element that the stage is going to process. So as the stage is sitting there, elements flow through, and those are the values you're going to process. In this particular example, your element is 1, 2, 3, and so on. So what do you want to do with an element? That's the element. You know what downstream is? Downstream is the stage that's next to you that you have a handle to. And you know what you will do on downstream? Gently push, right? So that's what the downstream is for. And the next question is, what in the world is underscore? Well, underscore is known as international symbol for I don't care. So if you don't care about it, just put an underscore. When I used to write code, before underscore was available, I used to use the word ignore because I like to write, useful code, easier to understand, so I'd put ignore. Ignore works fine until you have two things to ignore. So now you say ignore 1, ignore 2, right? And it doesn't feel really good. The nice thing about underscore is you can use any number of underscore. So you can say underscore comma underscore, meaning I have two things to ignore. What is underscore? I don't care, right? So just leave it alone. In this case, an underscore is supposed to be there for a state. Again, we'll talk about state a little bit later, but we're not dealing with state right now, so let's ignore it. So what am I going to do here? Now, here is where I want to pause for a minute. I want to do some extra work with this particular data, and you can refactor, optimize all of that. But the temptation a lot of times for developers is to say, oh, I need to implement multiple lines of code in Lambda, and the minute you put a curly, this is when I begin to cry, because this to me is a very bad programming practice. I tell people, you probably have seen this, right? Somebody has a curly brace, and they got 3 lines of code inside the curly. But it starts as 3 today. In one project, there was 75 lines of code within that curly. And everybody starts hating everybody else at work. So my rule I follow is this. And the rule I follow, again, this is really a discipline, right? And the rule I follow is lambdas are, I would say, glue code 2 lines are too many. So essentially, you don't want to write multiple lines of lambda. That's a really bad practice. So what I would encourage you to do is don't put curly when you feel that way. And again, imagine, if you wrote the code with curly, right? Imagine the consequence of that. You stuffed about 3 lines, 4 lines, 5 lines, and then you got the code working, but then you go home. And when you go home, your children come running to you and say, parent, how was your day at work? You're not going to make eye contact with them, right? You're going to look at the floor and say, oh, work, it was fine. Because your mind is, you shouldn't have put that curly, did you? Right? How do you look at the face of your children and say, it was a great day at work. Mom did, dad did, noble work today. Would you say that? Or would you say, it was fine? And then you go to the room, you start refactoring your code, right? Because guilt kicks in. So you have the power to do the right thing and exercise that power. And even at work, when you want to take a break and want to go to the bathroom, you're walking, your colleague is like, hey, and you can say, hey, you can look at them in the eye and say, hey, with pride, rather than, hey, I got to go back and fix that code, right? So let's not do that. So what we can do here is, we can say, what am I doing really here? You can say process element, or we can say filter out element, whatever the name is, call that. And you take the element and take the downstream and pass it to that element. How nice it is to write it, and you can even unit test that separately. So now I can implement that method right there and say element and downstream, and the IDE does most of the work for you, so you just need a little bit of a discipline. So what am I going to do here? Hey, downstream, first of all, what are we going to say here? Well, I have a predicate, pardon me. I need the predicate as well. So we'll take the predicate and pass it along with the element in this case. So element and comma downstream. So we have those 3 things we need right now. So here is our function. So what are we going to do within this? I'm going to first of all say, if the predicate test for the element comes out to be a true, then return downstream dot push the element. Otherwise, I'm going to pause here. Take a guess. What should I return? I'll give you a clue. It's true or false. What do you think? Should be true, right? Why? Because if you took an element, threw it away, you do still need more elements, right? Filter needs to keep going with other elements. So return true. Now you could say, ooh, Venkat, I can refactor this. Go for it. And if you're able to refactor it, okay, I'm a big fan of this mantra, right? Make it work. Then I would say, make it better. So evolve the code gently as time goes on. So let's run the code first of all. Notice 2, 4, and 6, which are the only even numbers in this collection, so our custom filter actually worked. But then you can say, dude, you don't need that much effort. Instead, you could have simply said a predicate dot test on the element or downstream dot push element. And you can then see if it actually works, right? And if it works, that's great. If it doesn't, you at least tried, and you can run that code as well. So essentially, the idea is make it work, make it better, and then find ways to refactor your code where you might be able to do it. So that's basically an idea of a custom filter, and it says, given an element, I either push it downstream or I toss it out. If I tossed it out, I'll ask for more elements. If I pushed it, I will tell what my downstream says. I'll convey it to the upstream. So that becomes a way to pass it. So far, so good? Okay. This is a great place. If you want to leave the room happy, that's a good time. But you chose not to. Fine. Okay. So let's talk about the flavor of gatherers. So what are the different flavors of gatherers? I just explained this concept here so far. So you decide what to do. You push it to the next downstream, and return the desire of the downstream. So we talked about this already. Let's go a little further with this, if you will. So we'll talk about the flavor of gatherers next. So here are the 4 flavors of gatherers. As you can see, we merely scratch the surface, right? Because this is a concept that's very complex. You got to take it slowly. So in this case, there are 4 gatherers, 4 types of gatherers. What's the first type of gatherer? First of all, on the left side, you have stateless and you have stateful. Real quick, which do you think is easier, stateless or stateful? Yeah, we all know that, right? Stateless. So stateless is the easiest thing to do. Stateful is more difficult. And again, you don't have a choice between these. Your domain is going to tell you what you want. If your domain wants something complex, that's what you need to do, right? Our solution should be consistent with what the problem expectations are. The other one is sequential versus parallel. Let's understand what that means. Sequential doesn't mean sequential, parallel doesn't mean parallel. So it is not about whether your stream is sequential or whether your stream is parallel. That's not what we are talking about. So what it's talking about here is, if your stage is in a pipeline, if you're on a sequential stream, your pipeline is sequential, no doubt about it, right? Because you're going to get one data at a time, and you're going to keep passing that data down, so your stage is going to do its work sequentially. But if you're on a parallel stream, so if you're on a parallel stream and data keeps coming, what does your stage do? Let's take an example. Can you think of way back in Java 8, can you think of an operator in functional pipeline where an operator was stateless and it can run in parallel as well? Can we think of one of those? It's stateless, doesn't care about what happens to neighboring elements, and it can be run in parallel. A filter, beautiful, lovely. One more. Map, absolutely. Both filter and map are stateless and parallel, right? They're parallel, why? Because if you put them in a parallel stream, they're like, bring it on. I can keep processing them any number of times as they come in. They're stateless because they only focus on the element you give them. You go to the filter and say, hey, I've got a question about the neighboring element. What neighboring element? I don't have any clue. I just do process for one element at a time, right? So that's an example. Can you think of a stateful intermediate operation? Not terminal, but intermediate. Something that needs to know about previous things. Thank you, beautiful. Limit is a great example. A limit is stateful. Why? Because a limit 3 says, I'm going to keep count of how many went through. Oh, 1 went, 2 went, 3, I'm done. So that's a state. It's got a count. So that's stateful. However, if you take an example of a filter, it can run in parallel, right? Because a filter can say, bring it on, keep moving, I don't have to stop for anything. But think of the method sorted, or think of the method distinct. What does sorted need to know? Sorted needs to reorder the element. It cannot just be in parallel. It cannot just run parallel, right? Because it cannot just say, as elements come in, keep going. It's like, whoa, 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 hang on. I got to resort these elements and then send them. So you can use sorted in a parallel stream, but how does that work? It runs parallel, and that's a junction point where the sorting happens, and then it can go parallel again. So if you look at the structure, it's not a cylinder, but it's like that, clock, right? Where the sand clock. The top is big, the middle is slim, and the bottom is big. So it's got to run parallel, but it's an intersection point. It's like, hang on, you all stay here, I want to sort, now you can go. So even though it is parallel, that stage may become sequential. So sequential or parallel means in a parallel stream, do you execute this in parallel? Or in a parallel stream, do you execute this sequentially? So it's not about the stream being parallel or sequential, it's about the stage being parallel or sequential in a parallel stream. So here is a way to think about it a little bit more. So if this is the parallel stage, it's like traffic going through the freeway. Every lane keeps moving. And this is the way you want generally the traffic to move, right? And by the way, this is exactly how traffic moves at 2 a.m. in almost any city I've been in. This is one of the reasons I love traveling in the middle of the night, because most local people don't bother to be on the roads, right? But what happens typically is there's a construction, as we all hate them, right? And construction happens everywhere. So when there's a construction, what happens? There's a little sign that says, that's okay, don't get angry. So essentially, all the lanes come together, right? So what's happening in this particular construction zone? The cars are all going in their own lane, but around the construction point, they all have to merge into one lane. Once you go past the construction lane, what happens? Everybody goes in their own lane. So it can be parallel before, it can be parallel after, but that stage is sequential. That's basically what a sequential step is. And then sometimes you can do parallel. But a parallel doesn't mean, if a parallel has a state, for example, or if you want to run it in parallel or want to manage some of the combining operations, then you may actually do parts of them in parallel, and then you may have this intermediate results that you can combine together and then send it off for further processing. So there are so many of these variations when it comes to gatherers. So when it comes to gatherers, here's what you need to know. This one is the simplest of all you can implement. It's a stateless, it's sequential, life is good, you can implement it. If you like a little bit more pain, you can then say, I can handle a little bit more pain. Then you can move towards a parallel and stateless. This is much less painful also. You say, you know what, I'm an adult, I can take more pain. You can come down here. This is stateful sequential. You say, but I really like a lot more pain. When I say a lot more pain, this is morphine level pain. You need some real things flowing through you to keep you really, conscious. That's when you come down to parallel and stateful. My recommendation is this. If you say, you know what, I'm working on an application, it looks like I need a parallel, stateful gatherer. My recommendation is don't. First, implement a stateful sequential, or a state, because you need a state. So stateful sequential. So here is the first thing I want to recommend about it. So the first question is, when it comes to code, never ask, is the code fast? This is a wrong question. But instead, ask, is the speed adequate? This is what you always want to ask. It's not if the code is fast, is the speed adequate? And if the speed is adequate, just say thank you and go home. There's more nice things in life than squeezing more performance out of the code when it's not needed. So write it stateful sequential. Stateful parallel. And say, stateful sequential. Implement it. Does it work? Yes. Is the speed adequate? Don't go to your colleague and say, is this fast enough? Don't ask them these questions. One of the rules I've learned in my life is never ask people questions for which you don't want the answer, right? The first rule I've learned in life is shut up. Because if I don't talk about stuff, I don't invite problems. So don't go to your colleagues and say, is it fast enough? Now they're thinking, maybe it's slow, right? Or don't go to them and say, I only implemented sequential, but if we need parallel, oh, we need it. Just be quiet. Enjoy life. There's more things to life, right? You implemented stateful and sequential. Does it work? Is it fast enough? Ship it. There is pleasure in shipping products than improving performance that nobody needs it. If then they say, we got a very large collection, performance is not adequate, can you do something about it? Then tell them, I'll think about it, right? And then experiment, play with it, see if it's worth it. So the parallel stateful is the last thing I would ever go for, and use your judgment. So that's all I'm going to say here. Enjoy the journey, learn about gatherers, give yourself a lot of time to play with it, and then, of course, have the wisdom how much of it to use. Hope that was useful. Thank you so much.